What's happening, everybody? Box Jellyfish here, and today I am back with another video. Today I am going to talk about the main theory on how the Earth's moon was created, known as the Giant Impact Hypothesis. The Giant Impact Hypothesis, sometimes called the Big Splash, suggests that the moon formed from the ejecta of a collision between the proto-Earth and a Mars-sized planetesimal approximately 4.5 billion years ago in the Hadean Eon, about 20 to 100 million years after the solar system formed. The colliding body is known as Theia. Analysis of lunar rocks suggests that the impact may have been a direct hit, causing a thorough mixing of both parent bodies. The Giant Impact Hypothesis is currently the favoured scientific hypothesis for the formation of the moon. There is lots of supporting evidence. Firstly, the Earth's spin and the moon's orbit have similar orientations. Secondly, moon samples indicate that the moon's surface was once molten. Also, the moon has a relatively small iron core. Next, the moon has a lower density than the Earth. Furthermore, evidence in other star systems of similar collisions resulted in debris disks. In addition, giant collisions are consistent with the leading theories of the formation of the solar system. Finally, the stable isotope ratios of lunar and terrestrial rock are identical, implying a common origin. However, there remain several questions concerning the best current models of the Giant Impact Hypothesis. The energy of such a giant impact is predicted to have heated the Earth to produce a global magma ocean. Furthermore, evidence of the resultant planetary differentiation of the heavier material sinking into the Earth's mantle has been documented. However, there is no self-consistent model that starts with the giant impact event and follows the evolution of the debris into a single moon. Other remaining questions include when the moon lost its share of volatile elements and why Venus, which experienced giant impacts during its formation, does not host a similar moon. So what is Theia? According to modern theories of planet formation, Theia was part of a population of Mars-sized bodies that existed in the solar system 4.5 billion years ago. One of the most important features of the Giant Impact Hypothesis is that the formation of the moon and the Earth align. During the course of its formation, the Earth is thought to have experienced dozens of collisions with planet-sized bodies. The moon-forming collision would have certainly been only one such giant impact, but certainly the last significant impactor event. There were smaller impactor events after this, such as the Late Heavy Bombardment, which was caused by smaller asteroids and occurred much later, approximately 3.9 billion years ago. Astronomers think that the collision between Earth and Theia happened at about 4.4 to 4.45 billion years ago, about 0.1 billion years after the solar system began to form. In astronomical terms, the impact would have been of moderate velocity. Theia is thought to have struck the Earth at an oblique angle, when the Earth was nearly fully formed. Computer simulations of this late impact scenario suggest an impact angle of about 45 degrees and an initial impactor velocity below 4 kilometers per second. However, oxygen isotope abundance in lunar rock suggests vigorous mixing of Theia and Earth, indicating a steep impact angle. Theia's iron core would have sunk into the young Earth's core, and most of Theia's mantle accreted onto the Earth's mantle. However, a significant portion of the mantle material from both Theia and the Earth would have been ejected into orbit around the Earth or into individual orbits around the Sun. Modelling has hypothesized that material in orbit around the Earth may have accreted to form the Moon in 3 consecutive phases, accreting first from the bodies initially present outside the Earth's Roche limit, which acted to confine the inner disk material within the Roche limit. The Roche limit is the distance from a celestial body within which a second celestial body, held together only by its own force of gravity, will disintegrate due to the first body's tidal forces exceeding the second body's gravitational self-attraction. The inner disk slowly and viciously spread back out to the Earth's Roche limit, pushing along outer bodies via resonant interactions. After several tens of years, the disk spread beyond the Roche limit and started producing new objects that continued the growth of the Moon, until the inner disk was depleted in mass after several hundreds of years. This event was so cataclysmic that estimates based on computer simulations suggest that some 20% of the original mass of Theia would have ended up as an orbiting ring of debris around the Earth, and around half of this matter merged to become the Moon. The Earth would have gained significant amounts of angular momentum and mass from such a collision. Regardless of the speed and tilt of the Earth's rotation before the impact, it would have experienced a 5-hour-long day after the impact. Not all of the ring material was swept up right away. The thickened crust of the Moon's far side suggests the possibility that a second moon, about 1,000 kilometers in diameter, formed in a Lagrange point of the Moon. Lagrange points are orbital points near two large co-orbiting bodies. At the Lagrange points, the gravitational forces of the two large bodies cancel out in such a way that a small object placed in orbit there is in equilibrium in at least two directions relative to the center of mass of the large bodies. The smaller moon may have remained in orbit for tens of millions of years. As the two moons migrated outward from the Earth, solar tidal effects would have made the Lagrange orbits very unstable, resulting in a slow velocity collision that pancaked the smaller moon onto what is now the far side of the Moon, adding material to its crust. Lunar magma cannot pierce through the thick crust of the far side, causing fewer Maria, while the near side has a thin crust displaying the large Maria visible from Earth. I hope you have enjoyed this video. Please like and subscribe, and until next time, goodbye.